I would like to welcome our guests here from DARKTRACE, who are just arrived from London, and Steve SOAR and Pippa COGSWELL. We will give us a presentation about enterprise immunization and how machine learning is evolved to detect the unknown threats. Yeah, Steve, it's yours. You can also have the headset or the microphone if you want. There, we have a headset over there. Or you want...
Yeah, absolutely. Ladies and gentlemen, first of all, let me just start by saying thank you to our hosts for having us here today. It's very much appreciated. And thank you for coming and listening to our presentation this afternoon. We aim to spend about 45 minutes talking to you about DARKTRACE, how we use machine learning. We'll talk about how we operate not only in the enterprise environment, but also in the ICT environment. So hopefully this should be a very interesting talk for you. I'm going to spend maybe the first 15 or 20 minutes just telling you fundamentally a little bit about our company, how we work and how the technology works. My colleague Pip, who is the real brains of the outfit, and also the probably the better looker of the two of us, if I'm honest about it, we'll then go on to talk about the really interesting stuff, which is how the technology works. We're going to give a very short demonstration of our UI, and hopefully you'll find it interesting. So to talk to you a little bit about DARKTRACE and where we come from. We were founded in 2013 in Cambridge in the UK, and the company was started by mathematicians and government experts. So really the company came from a spot where lots of people from government, UK government, who had been working in cybersecurity for many years, started to think about how we protect networks in a different way. And really thinking about, if we were to roll the clock back 20 years, would we be, putting up walls and perimeter defenses and solutions that relied on rules and signatures up around our networks in an effort to protect them? And really started to think about, actually, is there a new way to do this? Is there a better way to do this? We now have 18 global locations. We have over 500 deployments worldwide. We have HQs in Cambridge, as I said, very close to Cambridge University Maths Research Department, and also San Francisco. We have offices pretty much all over Europe now. We have a large presence in Asia Pacific. And the company's growing really, really fast, I'm very, very pleased to say. I'm also delighted to say that Gartner have named us Cool Vendor. And I'm also delighted to say that the World Economic Forum recently announced us as technology pioneers. So we fall in the footsteps of giants like Google and Dropbox and Twitter. So for a company like DARKTRACE, coming from Cambridge, only 3 years old, we're delighted to be able to say that we have accolades like that. Now, I touched on this very, very briefly when I started. DARKTRACE's approach is very different to some of the legacy approaches. We don't rely on rules, we don't rely on signatures, and we no longer believe that by building a taller and taller wall that's harder and harder to penetrate around your network, that you can keep the bad stuff out. We don't believe that the world looks like this anymore. As delightful as this hilltop village looks, we don't believe that the modern world operates like that anymore, and we don't believe that you can build walls around the network to keep the bad stuff out. Instead, the world looks very different. The world looks like this. There are no boundaries to our networks, be that our SCADA environments, our engineering environments, our manufacturing environments, or our enterprise environments. Actually, boundaries no longer exist in the way that we, I think, once believed they did. So this is how DARKTRACE views the world. It's ever-changing, it evolves really quickly, and it's really, really difficult to understand. And really, it was out of these principles that DARKTRACE first devised what we call the enterprise immune system, or the industrial immune system when we're talking about the industrial environment. So, to give you the analogy of how we start thinking about networks, we started to think about how the human body reacts. And the reason that we call ourselves the immune system is because we like to think of how we protect networks in the same way that the human body protects itself from threat or from risk. So if you like, we think of our perimeter defences, the big walls around our networks, as our skin. That's like our firewall. Okay, that keeps most of the bad stuff out. That keeps a lot of the noise away. That stops us, getting really bad stuff. The next layer down is our IDS and IPS and our SIM technologies, where, we are reliant to a large extent on rules and signatures. So we draw the analogy between the sort of the immune system and the way that, the nasty tummy bug that you got last year, actually your body now has a signature within it to deal with that. So next time that germ enters your body sees what it is and it understands what it is and it can start to deal with it. DARKTRACE operates at the next level up. So DARKTRACE is all about detecting the unknown unknowns. It's about detecting that germ that enters the human body that the human body has never seen before. Okay, so we deal with, we term it insider threat. So this is either somebody that's sitting inside the network with privileged access to your networks, that either does something, and I've got to say this is more often than not, does something stupid, or does something maliciously to harm network security, or, moving away from insider threat, those individuals that are outside the organisation but are making determined efforts to find their way onto your network. And I think we can all agree as security professionals in this room that actually if somebody wants to get onto a network and they're determined to do so, then they're probably going to do it. So the enterprise immune system and the industrial immune system operate in a brand new way. They sit right at the core of the network. Both are appliance-based software. And I'd like to tell you in a little bit of detail about how the software works and how it feels. So DARKTRACE is pure unsupervised machine learning. Our largest customers have several 100,000 staff. Our smallest customers have, I think our smallest customer currently has 14 members of staff. So it's a very, very scalable product. It deploys initially as an appliance, and we typically install from a tap or a span from a core switch, either in a data center or a head office. And our installation is 1 hour. That's 1 hour from the moment you as a customer say, we would like to see DARKTRACE on our network, to the moment DARKTRACE is on the network and it's working, configured, checked, and providing you results. It's 1 hour start to finish. The moment we deploy onto a network, we start to gather raw packets from across the network, and we start to create what we call a pattern of life for every device on the network. So just for sake of argument, let's take my laptop computer. So we start to see, in an enterprise environment, we would see laptops, desktops, telephones, printers, CCTV cameras, switches, servers, and we start to create a pattern of life for all of those things. And that pattern of life is really rich and detailed. And the reason it's rich and detailed is because we're capturing the raw packets, and we're processing them in real time, and we can almost get to the point very, very quickly where within a very small tolerance, we can predict what that device is going to do next. Now, that doesn't matter if it's a laptop or it's a piece of industrial machinery with an IP address that we can take the protocol off of. It doesn't matter what sort of environment it's in. And by the way, if any of you come from organizations that have an enterprise network and a SCADA network, we can operate in exactly the same way across both, and you can see all of it through one pane of glass, which is really cool. So let's talk about these patterns of life. So for my laptop, we would be seeing somewhere between 300 and 400 variables every second associated with my laptop's behavior on the network. Very, very quickly, we can get to a point where we know how that laptop's going to behave next. The clever bit is where DARKTRACE starts to see when it's expecting a laptop to behave like this, and it behaves like this. That's really interesting for us. Now, we have about 12 mathematical models that sit within the software that draw out all of these interesting anomalies, all of these behaviors that we're not expecting to see. As you can imagine, on a busy network, like the big busy city I showed you with the light streaming everywhere, there are lots of anomalies all the time, happening every second. What we really don't want to do as a technology is to show you 10,000 alerts every minute, because clearly that's not going to give you, as security and network professionals, what you want to see. So the really, really clever bit about DARKTRACE is our Bayesian estimation that sits above all of those anomalies. And the way I describe the Bayesian estimation is almost like describing an army of analysts. So it's like taking an army of analysts and putting above those 10,000 anomalies, those army of analysts, and saying to them, okay, I don't want to see 10,000 alerts. What I want you to do for me is take a very probabilistic and very humanistic approach to this and just show me the ones that I really need to look at. Show me the ones that are most probably going to cause me a risk on the network. And when Pip runs through the UI demo a little bit later, which she will do, I've seen Pip do this many times and she will do this expertly, you will see how quickly and easily you can then run down the particular threat. So, as I've said, it's unsupervised machine learning. It gives you a complete inside-out view of the network. We correlate behavioral analysis, so we look at behavior on the network and then we look for anomalies. We operate in real time. So again, the UI that Pip will show you as we move through this presentation is showing you a network 1 second behind network speed. So we do all of this as we go in real time. And it gives you a wonderful visualization upon which to base your investigations. As I've said, this is all about machine learning and mathematics. What really sets DARKTRACE aside from the crowd is that Bayesian maths that I spoke about, is that umbrella that sits above the anomalous behavior and allows you as the user to cut through all of the noise and just see the stuff that you're interested in. I hope that's a really a succinct introduction to our technology and how it works. I'm going to hand over to Pip now, who's going to focus as well on our industrial system, which I know that some of you are interested in. I do thank you for listening to the first half, and I'll hand over to my colleague, Pip.
Thank you. Thanks, Steve. Steve does have to run off shortly, so I'm going to jump in and take over. So basically, Steve has touched on the fact that we developed both an industrial immune system and also an enterprise immune system. They are similar to one another in the fact that they're using the same base, they're still using the same mathematics. The industrial immune system is basically an enhanced version in that it has an understanding of the protocols which are used within OT networks. Basically, I think Steve touched on it slightly a little bit earlier, which is they're both deployed in a similar fashion as well, taking a span from like a core switch or something like that to see as much traffic and user interaction or like PLC to HMI interaction or something of that nature as well. Basically, where did we come from? So I guess, why did we go into developing this? I don't think it's any surprise to the people sitting in this room as to why we did. It was looking at a lot of the challenges faced by OT networks and the state of the security. Basically, most of the networks weren't developed with security built in. Vendors weren't necessarily building that sort of information in when they were developing these technologies. There was a series of unsupported operating systems, patching, the usual sorts of things. It was very difficult to do these within OT environments. And of course, things like reliability, redundancy being very, very important, and how do you actually do something from a security perspective without causing too many or creating too many changes within those environments. So again, that's part of the reason for us looking at taking spans from a passive collection. To use a case study for you, one of our reference sites is DRAX. If you're not familiar with DRAX, DRAX actually creates 8% of the UK's energy, probably making it one of the largest suppliers from a generation point of view within the UK and also, I believe, Western Europe as well. DRAX adopted us very early on in the corporate environment, and then they basically came to us and sort of said, can you help us using these technologies? Can you help us adapt that to our OT networks? So that's basically where our developers and everybody went and put their heads together and came up with a solution that we could deploy into their environments. As I mentioned, we do have a lot of parsers that will work for those particular protocols, and again, we do find, because of the bespoke nature of these networks, that we do have to sort of develop some of the protocols as we go along as well. So we've got a number of those in development at this stage. I've put a little sort of icon there just to say Utility Week Awards. In December, pleased to announce that we went in partnership with DARKTRACE to those awards, and we won sort of the IT Initiative of the Year. We were up against a number of really, really innovative projects, including some of the smart metering technologies, some of the, I think it was surveying using drone technologies and what have you as well. So we basically came up trumps there as part of a security solution that we're able to offer that we found that a lot of other sort of OT networks weren't able to provide in the same way. Just to give you some of the examples of things that we found across our various installations that we have across OT networks. Probably, I won't go out and read them all there, but probably looking at the first one on the list there, which is, I guess, the most interesting in my mind anyway, which is basically where we observed a PLC sending unusual traffic. And we went back and had a look at the specification sheet for that particular device, and we couldn't find anything that indicated why this traffic was being seen. We could also see connections outbound from it as well. Eventually, we went back to the vendor and asked them what was going on, and the situation was that the vendor did have a backdoor installed for them to have remote access, and this was unaware. Basically, they were unaware of this going on. As I said, I won't go into too much detail there about most of the things that are on this slide, but you can see we've got remote access. It's basically trying to limit things like remote access, vendors coming in and plugging in laptops. If they're compromised and you're unaware of it, it will give you visibility into those sorts of things. New devices appearing on the networks. We do tend to find with OT networks that they should be, I guess, all in all, while they're transactionally high, we tend to find that they're more stable in the types of transactions that we do see in terms of which devices are talking to which. Usually that's in part because we see less users on those networks, but we will sort of alert on things like new users being created and those types of things as well, or new devices appearing, as I touched on. This slide actually is just some examples from our enterprise. I won't go and read them all out either. There's no particular reason for these events that I've actually outlined here. They were just a couple of things that I had on some of the reporting that I'd provided to clients over time. It's a whole breadth of things. I guess the point is with the technology is because of where we sit on a network and the types of traffic that we can see, we get quite a range of different types of threats that we can see. So it could be anything from, say, a compliance issue. So, for example, a user downloading a gig of data from a file server and transferring it out to Dropbox. It could be what looks like beaconing and malware installed on an endpoint, through to just general misconfigurations and what have you as well. Or an example one of our clients told us about the other day, which was seeing CryptoLocker version 4.0 land on their network, and then they were able to turn around and tell McAfee about that, so McAfee could write a signature and pass that back out to their clients. So that was quite a win, and an example of where, you know, not having to use signature detection for something to be found on the network. As Steve touched on, I'm going to try something really stupid. I'm going to try a live demo. We all know how those usually pan out, but I figure it's probably best to sort of try and show you as best as I can do. Bear with me 1 second. I'm just sort of going to drop the connection and try and reconnect just while I get internet access and what have you. Okay, so I might try and do both. Oh, I do not have to run. All right. So to give you sort of a quick demo, as I mentioned, basically this is the login screen that you would see when you do log into DARKTRACE. It gives a global view. Basically, the lights around the dashboard there are various subnets. When we start talking global companies, that becomes available to them. I'll just find my mouse now. Here we are.
I'm doing a useful job here, as you can see.
Should have switched to the headphones. Basically, if you hover over that, you'll get a summarization of the particular subnet that you're looking at. They are actually color-coded, so anything that shows up as yellow or something as a stronger color does tend to suggest that there's some sort of compromise or something that's been detected on that subnet. So in the top left-hand corner here, we've got a fairly sort of standard search bar. You can use that for host names, IP addresses, MAC addresses. You can do star.domain name or whatever it is that you want to put into there. Just to grab an example to begin with. If I can spell, brilliant. So I'm just going to hit down onto a domain controller and drill into one of those. Instantly, the first thing that you see there is sort of a visualization and representation of what the traffic actually looks like and who and what other devices this central device is talking to. So in the center here, we have our domain controller. If you hover over that, you get some summarization for it. You'll get IP addresses, MAC addresses. If it is a user client, you'll see the credentials that have logged into that machine as well. On the left-hand side, we'll see other clients that it's been interacting with, and on the right-hand side, other servers and what have you as well. Any sort of outbound connections to the globe will also be shown there. On the far right-hand side, you probably can't see it too well from where you're positioned, but there's a lot of summary information there. We tend to find that network engineers in particular really like that information. It's a full rundown on which protocols, which volumes of traffic, and it sort of summarizes all of that down on various layers as well. In the top right-hand corner, over here, we've got what is often referred to as TiVo. Basically, it's the time machine. You can roll back in time and play the traffic that's gone on. I'll show that in a minute. Down on the bottom here is probably where most of our security analysts start. This is our threat tray. So this is where the events the DARKTRACE is suggesting that you look into are actually being populated. We can see at this point in time we're showing 4 incidences for this particular network. It's also summarising the last 7 days. Down here in the bottom left-hand corner, you can actually, as with a lot of these sorts of products, you can set which time you want to look at depending on how your SOC is set up. So you might want to look at the last 24-hour period, last 7 days, last 4 hours, depending on how quickly you look at these things. We can divide up how we look at things via users, devices, or models breached, depending on what's of interest to you. And you can also, we've got a slider bar there, so depending on the operation requirement of your environment, so for example, some of our smaller clients will tend to have that up quite high, so they're only looking at the most anomalous activity on their network, through to a lot of our finance clients, which basically have pretty much a no tolerance policy, and everything is, down below 20% usually they're operating from, so pretty much anything on their network that gets flagged, they need to have a look at. It's quite quick from a security analyst point of view. You can just sort of hover over any particular feature and get a quick summarization of what's gone on. I find that quite a useful thing as a former security analyst. Depending on your level of investigation, we can drill in multiple different levels. I won't get too carried away on some of that today. I know that we are short for time. But just, you'll get a very quick summarization for which IP addresses and hosts and things like that were being discussed there. A little bit around which particular model that was breached. We can go on and just do a search and focus in on that particular item, or we can go in and get additional log data as well about what else happened from the transactional point of view. So for us to do that, in this instance, we're just drilling down a little bit further and we can see which model has been breached. At this layer as well, we can pivot off to multiple different graphs. We can see which devices are similar to other devices on the network and where they may have deviated from that normal behaviour. We can filter things, we can do packet captures, we can integrate with other SIM products. There's not a lot that you can't do, I would say. You can colour code different communication strings out to different destination ports or whatever, just to make visibility easier in the way that you're looking at it. I'll close that off and just do a quick sort of playback or something like that. As I said, from a visibility point of view, I've just done a 1-minute playback on the domain controller to see what it's interacting with. The devices that have hovered as yellow will have had some form of a breach on them. I can hover over those and have a quick look as to which was the device and what's going on there. You can see, or you may not be able to, I'm not sure, but we've tagged up that item as part of a watch list. You can tag things, you can label things, so you can label up subnets, or you can label up and say, this is the CEO's laptop, or this is a critical device that we have in our network, so it might be something that you will actually want to pay more attention to, I guess, ultimately. So as I said, that's just a quick sort of 1 minute playback, the interactions between that domain controller, clients, servers, and the outside world. Steve, other things that I might want to demo?
No, I think that's, I know we are pressed for time, and I hope that's giving you a sort of decent overview of what the UI looks like. I think the thing to mention there, just as Pip sort of goes back to the presentation, if that's okay, Pip, is that, you know, this is the visualization that you see pretty much from the outset. So as I said, we install in about an hour. You log into this UI via your web browser, and that's what you would see within the first, you know, few hours of our deployment. And of course, DARKTRACE never stops learning. So the longer it's on your network, the longer it's learning, you know, learning self, as I described earlier, really the better it gets, and the more incisive that UI gets for you. I hope that's given you a good overview. What I will say is that we are, my colleague Milka, who is at the back, is in the hall. Is in the hall downstairs, and we also have the demo downstairs. So if you would like to run through that in greater detail when we have a bit more time, you know, I'm sure Milka would love to run through that with you. So please don't hesitate to come and find us. I'll pass back over. So sorry, yeah. So the very final slide, DARKTRACE in 2016. We are proven to work at scale. Lots of our effort at the moment, or over the last few months, has been into virtualized environments. We now operate on virtualized environments all over the globe. We have what we call vSensors, which we can deploy into very heavily virtualized environments, which work alongside our existing devices and software. I guess the last thing that I have to say, we have a major update to our technology, which is due to happen today. It's being announced at the large conference, which I'm sure you're aware is happening in San Francisco. It will be announced today. I'm sure there'll be mention of it in the press. I would encourage you to have a look at that. We are extremely excited about it. It is an addition to the existing technology. It's a major addition. And as we've put there, without giving too much away, this is all about the machine fighting back. So I would encourage you to have a look at that. Please do stay in touch. Please go and see Milka at our stand and get an in-depth demo if you have the time. Please do look out for the press release later today. I won't give too much away. My marketing department would absolutely kill me. But it's a really, really, really exciting and great addition to the technology, which we're extremely proud of. So do keep an eye out for that. I think the last thing to say, and I'm sure I speak on behalf of Pip and myself when I say this, it's been a real pleasure to talk to you. Thank you for listening. I've now got to battle through the snow up to Munich Airport and hopefully not miss a flight. So I do appreciate you coming upstairs 5 or 10 minutes early there. It's really very much appreciated. Thank you for listening. I don't know if you have anything to say, Pip. Thanks very much. Thank you.